In this video we're going to consider composite transformations of the plane, which really just means more than one transformation together, and how we need to think about the order of those transformations and how maybe we can even represent those using a single matrix. So I want to start off with an example. Let's consider a point in the plane with coordinates 3, 4, and let's think about what happens to that point when we first of all reflect it in the y-axis. So what's its image going to be if we reflect it in the y-axis, followed by rotating it by 120 degrees anti-clockwise around the origin. Now we're going to think about this using matrices, but maybe it's worth just quickly visualizing. So let's do a little sketch here. We've got a point with coordinates 3, 4. And we're first of all going to reflect that in the y-axis, so it's just going to come across the y-axis here. So let's call that first image point P dash. And then we are going to rotate it anti-clockwise about the origin by 120 degrees. So thinking about the angle that it makes there, we want to go 120, which would be, what, maybe about here, let's say. So it's coming around, staying the same distance from the origin, and we'll call that the second image point there, P double dash. So that's the point that we're interested in finding the coordinates of. Okay, so let's think about the two matrices that we would use, and then we'll think about the operation that we need to perform. So reflection in the y-axis. That's our matrix that we use the notation M subscript Y for, and it had the effect of, it took the point 1, 0 to negative 1, 0, but it didn't have any effect on the point 0, 1. So that was our matrix for reflection in the y-axis. And then our matrix for rotation by 120 degrees. We could use the notation R120. And remember, for this one we go cos, negative sine if we're going across, positive sine down here, and then positive cos over here. And let's give those some exact values. So 120 for cos, both of those would be negative a half, wouldn't they? So that one and that one, negative a half. Sine 120 is going to be positive, so that one's going to be root 3 over 2, which means the negative of sine 120 will be negative root 3 over 2. So those are the two matrices that we can use to produce those transformations. But now we need to think about how we would do that operation. So come back over this side, and if we were going to do the first transformation to find P dash, we would be saying take the original point P and multiply it by the matrix that produces that transformation. And then we would be saying, so P double dash is going to be equal to R120 times the image point that we had, which is R120 by my times P. Now, because matrix multiplication is associative, in other words, as long as we don't switch the order of the operators around, we can group them in any way, then we can actually do this alternatively by just multiplying the R120 and the M reflection in the y-axis by each other first, and then multiplying by P. Doesn't really matter which of those last two lines we go, but the significant thing that I want you to notice there is that the order of the transformation matrices is the opposite, if we're reading from left to right, is the opposite of the order in which we're doing them. So the rotation has to be listed first in the operation, even though it's the last transformation that's being done, and the reflection is listed next, even though it's the one that's being done first. And hopefully you can see from the way that I've sort of written it here and done these steps why that is the case. So let's write that in our notes here. So then we can say then P double dash is going to be equal to 120 by my by P, and that's since the reflection is first. And we could also write that as R120 times my times P, and that's since matrix multiplication is associative. Associative. I think I've thrown an extra S in there, haven't I? Let's try and write that properly. Associative. Alright, which means we can't flip the order, but we can group them in a different way. So let's actually go through now and do this operation with this example. So let's say the coordinates of the second image point are going to be equal to, let's write in, I might need to do that slightly bigger. So subbing in here, our R120 is negative a half, positive root 3 over 2, negative root 3 over 2, and negative a half. Our reflection matrix, negative 1, 0, 0, 1. And then our starting point coordinates were 3, 4. So I'm going to multiply these first two matrices together first. So going row by column, I'm just going to get positive a half there. Going first row by second column, I'm going to get a negative root 3 over 2. Second row times first column will give me a negative root 3 over 2. And second row times second column will give me negative a half. Alright, and then doing that product there. So what I'm going to get, 3 over 2 minus, well, let's leave it, I think, over 2, because then we can probably write it a bit more neatly. So that's, maybe I'll just fix that first one up. It's a bit hard to see, that's a 3. So that's the x coordinate of the image point, and then multiplying the second row, so we're going to get negative 3 root 3 over 2 minus 4 over 2. And the reason for not simplifying those is maybe it would be a bit neater to write them as a single fraction. So 3 minus 4 root 3 over 2 is the x coordinate, and negative 3 root 3 minus 4 all over 2 is the y coordinate there. So that's the coordinates of the final image point. So is the point with coordinates 3 minus 4 root 3 over 2 and negative 3 root 3 minus 4 over 2. And I guess if you wanted to jump on maybe Desmos or something like that, you could plot the coordinates of that point there and just see if it does indeed look like that graph, that sketch that we did at the start. Now, before we finish up here, though, we should say a little bit more about what we've produced there. So we've got a matrix up there, which we worked out, which was the result of doing R120 by my, which was equal to, so that's this matrix in here, isn't it, where we multiplied? So it's the one that's a half, negative root 3 over 2, negative, root 3, let me make that a bit neater, negative root 3 over 2, and -1/2. So that matrix that we produced there is a single composite transformation matrix to produce that reflection followed by this rotation here, R120. And we just need to note that if we wanted to do them in the other order, so if we wanted to achieve R120 followed by reflection in the y-axis, we would use the matrix T equals my R120. So that order that we write them in is the opposite to the order that we actually perform them in, and that's because the one that is done first has to be kind of closest to the point. It has to be done first, so it needs to be next to the initial P value there.